but there is a big area for research in any sector that you mention. But let's go back to the construction. Sustainability in construction have a many aspects, have a many angle, and have a many different criteria. So before we go through the detail, this is the actually title that we're going to study today and also next week. There's some uh, titles such as value management, BIM or BEAM, or you can see here, you can read. So the first thing is introduction here. We talk about the sustainability, right? And what is the method of sustainability? How you can measure environment issue. We call it life cycle assessment or LCA. If you're interested, you can research later. You can study about it. LCA. This is the method, very worldwide recognized method to measure, to evaluate the environment emission. So when we want to measure the emission from building, the impact from construction, first of all, one of the main criteria that we have to know is the boundary of our research. The boundary can be defined as cradle to grave, as you can see in your screen, or it can be defined as cradle to cradle. Or also we have more than these two, we have another boundary. We call it cradle to gate. How you know which one you have to choose is very important because it has impact on the outcome of your research. It has impact on the outcome of the results. For example, if you choose cradle to grave or cradle to cradle, and you want to compare two buildings, one constructed by brick, for example, another constructed by concrete. If you choose cradle to grave or cradle to gate, you will achieve the different result when you choose cradle to cradle. And in the detail, for example, you and me are researchers. We're working on the life cycle assessment on building. We have same case study. When you choose cradle to cradle, and I also choose cradle to cradle, we also might get a different result, a different outcome. The reason that the assumption we get, please turn off your microphone. The reason why you and me get a different result is written back what assumption we choose. I will give you more examples. So just keep in your mind cradle to grave, cradle to cradle. Another one I just add to you, cradle to. Can you tell me what the third one I just told you? Let's see who's listening carefully. What was the third one I just introduced? Cradle to grave, cradle to cradle, and cradle to gate. Okay. Also, it can be gate to gate. That's why if we study on the same case study on the same scope, we want to assess the environment issue of the building, we might get a different result and all may be correct. Your result might correct, my result maybe is correct, but it depends what system boundary we choose. We have to justify. You have to justify why you choose cradle to cradle, why you choose cradle to grave. Okay, so how we have to do that, or how we must know we are correct or not. First of all, system boundary. Every single step of the construction has been defined by some standard. We call it 158.04. This standard is very famous in the Europe. We have another one for worldwide, but it's not limited to Europe. Also, if you do the study, if you do the research in Malaysia, in Japan, in any country, you still can use this framework, this system boundary. So let's see what they have in the detail. Production stage has been categorized from A1, A2, A3. The material extraction is A1. They transport the material to factory A2, and another process in the factory is A3. This is mandatory, no matter what boundary you choose. Either is cradle to gate, cradle to grave, cradle to cradle, or like this, cradle to cradle. This A2, A1, A2, A3 is always mandatory. Okay, you cannot neglect, you cannot omit one of those. Okay, then the construction process stage on the site. Transport the material to the site A4 and the construction process A5. Anything related to the construction process A5, like the machinery, the equipment we use, when we have a vest, everything is part of A5, which is could be optional if you assume that your study is cradle to gate. But if you want to study cradle to grave, you have to consider A4, A5. It's mandatory, right? As you can see here, another stage is use stage B1 to B6. Okay, end of life also have four stage C1, C2, C3, C4, and finally the benefit and load. Can you tell me what is the benefit and load? You can guess, thinking and guess what is that? Why we have such that stage in the construction? Can anyone tell me what is that benefit and load in the construction? Read from top. Production stage, then construction stage, then use stage, then end of life stage, and then benefit loads. What is that benefit loads?
No idea, doctor.
Okay, no problem. If you have idea, you can share. As imagine what is the construction stage from beginning to the end, and refer to previous slide. Then think benefit and load. See this picture, see this slide. What is the benefit load here? You think?
Sorry, doctor, can I ask you a question?
Yes, sure.
Actually, I don't know what's the meaning of cradle. I don't understand.
Cradle. Okay.
Yeah.
Thank you for asking me. Cradle. Let's take a look in the picture, and let me change the size of this picture. Okay, take a look here. Resource extraction. This they call cradle. Means when the baby born, the first stage is cradle. If she or he want to grow up, they put it in the cradle. Means that is first beginning, early stage. This one we call cradle. Extraction material. What material you have in mind? Is that wood? The cradle is extract from forest. Is that brick? Extract the soil. Concrete, steel, extract from the mine. That's the first stage, right? This one we call cradle. Grave, in another hand, is the last stage that dispose material in the landfill. For example, there is a building constructed from concrete. What happened to the concrete? When the concrete building demolished, the wall demolished, what we do? The material we dispose to the landfill. We find a land that is not belongs to anyone, so they transfer that material to that land and just leave it there. This is called grave. Land is the first, the cradle is the first stage that construction can be a start. Actually, material production will be a start. After cradle, the material transfer to manufacturing, the construction site, then occupancy, like 50 years, 60 or 100 years is variable. Depends to the country, depends to the material. It can be different. Demolition and disposal is great. Okay, I hope you understand what is the definition of cradle. So now let's go back to our question. What I asked you, what is the benefit and load? Take a look carefully in the picture, in the slide, in this figure, and tell me what is the benefit and load.
I am not sure, but I will answer. So when it is cradle to cradle, we reuse our material because we have only limited material. We have only certain amount of something like silicon or something like that. We have certain amount. So if we recycle it, we can use it again, and it's more sustainable development. We don't run out of material and stuff.
In the future? Yes, yes. So, literally tell me now what is the benefit? Your explanation is correct. You understand the issue. So, what we should call the benefit and load?
Cost reduction, sir. You did not turn on your microphone, sir.
Actually, I turned off my headset. The battery finished. That's why it automatically turned off. So, what is the benefit now? Which stage we call benefit?
Benefit for life cycle of building,
Okay,
cradle to cradle. You mean that
in general.
in
In
general?
general, yeah.
The
What?
first benefit, which is the environment, which is we don't burn any waste material that we use
Mhm.
in building. Also,
Okay.
we save the environment
How?
from pollution
How? How we do that?
because we use the waste material to
Mhm.
recycle it.
Which stage? On which stage we do that?
We in stage of the recycle houses.
Means after demolition.
Yes.
Okay, that's good. So there are, thank you. That's correct. When we talk about the benefit and loads, we are referring to this stage after demolition. We demolish the building, now we have so much material: wood, aluminum, steel, concrete. So those material all can be recycled, some can be reused, not all can be. If we assume the building is concrete, so the concrete can be recycled. The steel bar inside concrete structure can be recycled. Some material, some windows, doors might be reused. What else? Recycle, reuse, for these two for benefit and load, right? Means have a positive impact on environment. We don't need go and extract new material. We have one more activity in this stage. Yes? Okay. We have, I thought I heard something. Recycle, reuse, what more?
Reduce.
Reduce, you said reduce. Did I hear correctly?
Yes.
Reduce. What do you mean by reduce? May I know? Because the building already demolished after 100 years. So you can make recycle out of that material. You can reuse some of them. What else? When you say reduce, how reduce it in that stage? In this stage, demolition to this stage, can we reduce anything? Yes, in the construction, yes, you can use of some recycled material or reuse materials. You can do that, reduce. But in this stage, we can do recycle, we can do reuse, and another one, incineration. Do you know what is the incineration in that stage?
No.
Burning this the stuff on fire.
Yes, Muhammad Abdulrahman, repeat
Yeah,
again.
burning the stuff on fire, like the
Oh,
material.
very good, very good. You're almost there. Okay, burning what? What type of material we can burn?
The type that when it's burned, it will not affect the environment. For example, if we have toxic material, if we burn
Okay.
it, it will
Uh-huh.
affect the
Mm-hmm.
environment in a bad way. But sometimes another materials that will just take space in the landfills, and we don't need it. And burning it will not be harmful or will generate more beneficial substance.
Oh, okay. With part of your answer, I totally agree. But with another part, we need to have more discussion. First of all, my question: what type of material we can burn? We go step by step to the end. Can we burn this steel? Can we burn the concrete?
We can burn the steel to make another plates, but we
That's we
can.
call recycling. That's we call recycling. We not call incineration.
Okay.
But there is a material we can burn. Do you know which one? Do you have a table front of you? What's the material of that table?
Wood.
Wood. Wood you can burn, right? By burning wood, we call it incineration. So you told me just now we burn it to avoid the pollution. I totally agree with you. But I want to know how. Because when you burn something like wood, it automatically releases some emission to the environment. So how the incineration can have a benefit to the environment? I repeat again, don't rush to answer. We burn something, it already emission like CO2 emission, carbon dioxide to environment. Then how incineration, burning wood can have a benefit to environment?
We produce it to produce energy.
Energy, yes,
Yeah.
that's great. Electrical energy, for example, correct? Yes, Naiman, your friend was correct. So let's go one more step beyond this definition. You burn the wood to produce electrical energy instead of burning fossil fuel. Burning wood produce much less, a little carbon dioxide. But if you burn the fossil fuel, like coal, it produces the high amount of dioxide carbon to emission. That's why incineration of wood in the last stage of the building have benefit to environment. Plus another reason we burn the wood in the last stage, because I think I told you already in the last section, the wood already have plenty of CO2 emission inside its body, which absorb during it was tree. Still there. After 50 years, after 100 years, the CO2 is still there. If we compose it to the landfill, means just put it in some land, the CO2 again will go back. The high amount of CO2 go back to the atmosphere. So when you incinerate, it release it. The amount of dioxide carbon is much more less. That's why it has. We call it benefit. So all the material in building either can be recycled, can be reused, or incinerate. That's how we get benefit from the material in the end of life of the building. Okay, this one we already discussed. Now take a look here. We just mentioned in previous slide some stages mandatory. This one I take from the previous study, previous publication. You see this study, he or she choose A1, A2, A3, A4, A5, and C4 as disposal. They neglect other stages because they didn't claim that our study is cradle to grave. So that's optional. Or another study, you can see A1, A3 is compulsory, and also they choose B1. In the use stage, we have 7 different categories: use, maintenance, repair, replacement, refurbishment, energy use, which normally is 70% of the emission during building life cycle is contributed to the energy use, either heating or cooling. Also lighting is considered. Water usage, this all related to use stage of the building. So let's have one assignment. You write it down now, you do research, then later submit to me. Find out the difference between replacement and refurbishment. In another hand, the difference between B4 and B5 and B2. Okay, this is your assignment. Find the difference between B2, B3, B4, and finally B5, and make a conclusion. Your report should not be more than 1 page, maximum 1 page, but should be very comprehensive, okay? Find the difference and get conclusion. That's how you have to report, make your report. You can write it down or have a screenshot, it's up to you, or take picture with your phone. I will share with you the link for submission later after class. Your report should be typed in the Word. Do not use the pen or pencil, and avoid from plagiarism, means do not copy paste from another source. Read it, read from internet, from journal, from paper, any source you found, and then write it down from your own language, from your own thought, okay? Strictly avoid any copy paste. I will check it actually, we have to check, that's part of our rule, we have to check. Okay, so that's your assignment. Now let's continue. So in this slide, all the stage try to be actually clearly mentioned. Raw material, transport, manufacturing is A1, A3 to A3. The construction stage, transport A4. You see we have another transport here. And construction process A5. This is the B we just discussed. And end of life, C1, C2, C3, and C4. All the recycle, reuse will be in the D section. Okay, that's it. Now, the sustainable construction concept. When we talk about construction, sustainability in construction, there are so many things that we can assess. If we want to have a zero emission building, we have to follow so many instructions. For example, one of them is related to daylight. Not only for have a brighter room, but also we can actually use from solar panel to produce the electricity. Okay, and use from the water from the raining as a supplement for inside the building. The material we used, we described for the building wall, building roof, enhance the stakeholder well-being. You can see in the down picture. And there are so many other items. You can take a look later. So if you want to do project in the future, you don't need to calculate all of these criteria, all of this actually technology. Okay, one might be enough, but you have to do it in the efficient way. Okay, there is a task for you for also this part of your homework, or I can say assignment. You may take a note or take a picture. I also can share with you the file later. You have to answer these 3 questions and make a report and submit Let's make it, name it task 2, and the previous one we make it task 1. Okay, this was task 1, another one, task 2. This also should not be more than 1 page, maximum 1 page. I will share with you the file later, you don't need to write it down. Let's proceed. So, element of sustainable design. When you imagine you are a stakeholder, you are project manager, PM, and you claim my building, the building I just constructed, is sustainable, have the sustainable element. As you might know, there is a ranking system that will give a point to your building. It have some instruction. They will give you mark, like how you're a student, you get mark in any subject. They will give mark to your building that how it's close to be full sustainable or in vice versa, it's not sustainable. Okay, that depends if you follow all these elements like building envelope, the site, building oriented, the cooling system, energy system, water, and the element related to future of the planet. So what is the difference? Building envelope. Choose the structure and the element that minimize energy loss and maximize the thermal barrier, which means when you turn on your air conditioner and you use it like 1 hour, when you turn it off, it's take longer time that the temperature of inside increased. Means the cool air not escape easily. That's the element related to the building envelope. So if you use better insulation, you get a better outcome. The issue related to the site, as you can see, choose the energy efficient location, infrastructure, mass transport easily accessible. And there are other elements you can read later for building oriented. Capture natural energy, such as the sunlight, or you can use of the passive air cooling inside the building. So reduce using active ventilation means you use less air conditioner, instead using the outside air, both during daytime and also nighttime. How much that possible in Malaysia, I cannot give you the answer. It's 100% working because, let me ask you, why the natural ventilation is not work efficiently in Malaysia?
Because the weather very hot.
Very hot. Okay, there are some places in Middle East, in the Africa, that is more hot than Malaysia, but they easily use of the natural ventilation. Why is that?
Rapid change of weather.
Change of weather. Can you explain more? How change means what exactly?
The weather is not the same throughout the year.
Oh, let's talk about one day, okay? Like today. The weather is stable. Sunny or cloudy is the same throughout the day. We still cannot use of natural ventilation. Why?
Is Malaysia very hot and humid?
Yes, that's completely correct. The natural ventilation system, they call it such as stack ventilation, can be used in the arid and dry area, dry climate. The area like Malaysia, which is very humid, have high humidity. If raining, I think the humidity will reach maybe to 90%, and most of the days is around 80%. That kind of system is not really efficient, it's not working. So HVAC system, okay, we don't have heating system in Malaysia, but rather we have cooling system, energy designed to reduce the loads. Actually, this energy have a straight connection with building envelope. If we have a better building envelope, we can save the energy somehow. And regardless that, there are some techniques to achieve the energy and use it in the building, such as solar power, wind generated power. In some countries like Europe, they not only government use of this technique to produce electricity, but you can find some households, some people, they installed the smaller version of the wind turbine in their house to produce the electricity, because in that area there is a windy area. The speed of the wind is high, but it's very hard. We can claim it's working in Malaysia because here it's not recognized as the high windy. Okay, the future of the planet built with durability as a goal, design the next life into the first one design, and use of biological filters, and the rest you can read. This all part of constructing the sustainable building or follow the sustainability in your construction. So if you build the building recognized as sustainable, not only you save the planet, but you save the energy. There are some benefits of sustainable design. As you can see, this is related to so many criteria that related to the energy, related to the material, related to the water, which already we described it in previous stage, but it would be good you also study this figure here. So next, principles of sustainable construction. What is the principle? There are some indicator that you can see in the picture, such as procurement. I think we already discussed what is the procurement, right? The environment, site, material selection, waste prevention, recycling or reuse of the material, energy, building and material reuse. Okay, if we have reuse here, then number 5 is only recycling, health, safety, and indoor environment quality. So the health safety is not about the environment, but it's about the social life cycle or social sustainability. We discussed about it last week, and we had so many, like 20 different criteria. I ask you to guess which one is environment, which one cost, or social. So now let's take a look on the figure. Well, this one about the CM, PM, SM, leave it aside. Now let's focus on these 9 elements, which after the construction means during the occupancy of the building and the end of the life, which is related to benefit and loads. Some of the criteria here, like energy, is related to the construction to occupancy stage. Some others, such as recycling or reuse material, related to the benefit and load of the building. Yeah, of course, we can dig deeper. For example, okay, we just explained it. I think that's what's enough. I told you about recycle, reuse, energy. Now let's go to the next stage. Procurement, site environment, material selection, waste prevention, recycling. The next energy, building material reuse, health safety. Health safety is mostly related to the worker, but indoor environment quality is related to the residents, the people who live inside the building. This might be the duration related to 50 years, the people living inside the building. But this health and safety, maybe only the 6 months or 1 year, the duration of construction. The procurement also same, related to the construction stage. So now we have a very short definition for procurement. The activity undertaken by client is seeking to bring about the construction or refurbishment of the building. So I already discussed about the procurement during the construction stage. You remember we said we're going to have a bidding or tender to find the supplier and invite them for providing our material. So this stage is the same but related to another category. Okay. I think you can read this very clear definition. So process of sustainable procurement, tender specification, pre-qualification, award, and contract stage. The next item or element of sustainability is site environment. So in previous slide, we just mentioned why the site is important, because the site is accessible by road. Actually, it's at a place that have a less noise for the neighbor. But in some construction techniques, such as PPVC, prefabricate, prefurnish construction technique, means they create the whole building in the factory and transfer it to the site, means we have a minimum noise on the construction site. We don't have exactly this problem. Material selection, which is very important because every material have their own emission. And there is one more thing I like to discuss with you. Let's assume you choose a building, you choose the building material that is very environment friendly, okay? Such as, can you give me an example of the material is very environmental friendly?
Wood.
Yes, wood. Okay, that's very good. Keep it here. You construct a building with wood and you same time you construct another building by concrete. But the one you create by wood, you use no insulation on the wall, on the roof. And in vice versa, the one with concrete, you use very good insulation. So it not let the cooling system waste. Because you are going to use those buildings for 100 years. So if you calculate cradle to gate in the last stage, you consider all the possible scenario. I'm talking about take a look here. If you consider all A1 to C4, regardless D, okay, it's not compulsory. Just A1, A3, A5, B7, C6. So you might use of wood, which is very environmental friendly. But during 100 years, every single day you use air conditioner, you have to use more electricity to make inside the building pleasant temperature for resident. But the one use concrete and use proper insulation, use every day 20% less energy than your building. Can you claim the wood building is more sustainable? Definitely cannot, because if you evaluate during 100 years, you might see the wooden building has really high amount of energy expended for the occupancy. So it's not enough you choose the more sustainable material, but that's interesting about sustainability, because there are so many things need to be gathered. Then you can call this is the sustainable construction I did, or we did, our team did. Okay, the next one, waste prevention, design for durability, design for disassembly, and use IBS, or another one I can add here, PPVC. You can Google and find what is the PPVC. However, I just explained to you. We construct the whole building in the factory and then transfer by lorry to the site. But we not assemble the whole building at the factory. We just create, they just create room by room. The bedroom separate, they manufacture, and then transfer one by one. And on the side, they use a crane to attach like a logo. You know what is the logo, right? They attach the bedroom, the kitchen, everything's the bathroom, bedroom, everything's dining room. They just attach to each other and they construct a new building. That's not limited to 1 story, 2 story, can even construct up to, and I mean multi-story, like 10 story or 12 story can construct by this technique. IBS, in other hand, is different. Only the wall panel constructed in the factory and then transferred to the site. But in PPVC, whole room. Okay, that's the difference between IBS and PPVC. And PPVC is quite new technology in Asia, like Malaysia, Singapore. There are so many factories currently working in the JB, Johor, and they transfer to the Singapore. I think it should be last 2-3 years, or maximum, I think 5 years. Okay, the next item is the recycling, which I think is very easy to understand for you. Energy efficiency can be maximized by utilizing material and system that meet the some criteria as following: material, component, system that help the reduce consumption of building, just like the example I gave you, comparing wooden building and concrete building with insulation and without insulation. So here, many materials can be salvaged from demolition and renovation site. These materials suitable for reuse, such as mentioning here, you can read it. Wood, actually, for the brick, mostly used as reused, not recycled. But all this material can be reused. Same time, they might have actually other possibilities, such as, for example, wood can be incineration, but same time can be reused, but maybe different application. Okay, last time the wood in one building used as wall, as floor material in multi-story building, like two-story building. Nowadays, they can construct with wood up to 12 or 13. Currently, they do in Europe. But after 100 years, they not use the wood for the same application. Maybe they use it as window or door, okay? They reuse it, but different application. Okay, health and safety, we already discussed about it. This related mostly to the social life cycle. As you can see, everything in the sustainability is look like chain to each other. They connected. Now we talk about indoor environment quality. So if you have a flashback, it's contributed to the another criteria such as proper insulation, or it's connected to the energy. It connected to the strategy we used for sustainability, such as stack ventilation or use of passive ventilation. Might not be work in Malaysia, but we're talking in general, okay? So, all this strategy we just reviewed can be applied in before construction, during the construction. Some of them can be applied after construction. For example, a technique like orientation of building is compulsory implement before construction, okay? It cannot be changed after construction. Some of those can be applied, yes, during construction or throughout the construction project life cycle, such as using of the wind energy. There's always a chance to install some equipment, use of the wind power or rainwater. Even if we not design it before or during the construction. Maybe it can be done 20 years after construction done, but it depends. Some of them, as I told you, some of those cannot be done after construction. Some, yes, it's possible to design after. Any questions so far?
No, doctor.
Okay, if something is not clear for you, you have to ask, okay? Because it's very good you learn everything here. Okay, please make your attendance.
Doctor,
Yes.
last week you said this session we will have quiz. So is there any quiz or not?
Sorry. Would you repeat again?
Uh, Last week you mentioned that today we will have a quiz. So
We will have increase.
quiz,
Okay.
quiz. So
Yes.
are we going to do a quiz or not?
We're going to have a quiz yet, not today.
Not today.
I will update you later, okay?
Okay. And for the task 1 and task 2, what is the due date?
Okay, for the task, I will tell you when I share the link with you for submission after the class. The date normally should be in 1 week, means next Saturday, definitely.
Okay, thank you, doctor. That's great.
You're welcome, you're welcome. So, if you make your attendance, I wanted to show you something. Can anyone tell me what is this? What crossed your mind when I wrote this abbreviation here? Have you ever heard of GLT, CLT, LSL, or NLT?
No, doctor.
Okay, anyone know? It's okay if
No,
you don't know.
doctor.
I want to explain. Okay, no problem.
No, doctor.
So When we discuss so much about the wood, right? So it might, I don't want you to misunderstand. When I'm telling you wood, you just imagine the solid timber, the wood they after they cut the tree, they cut this in the proper size in the mile and bring it to the site. Nowadays, the use of that kind of timber is become lower and less actually in the construction industry. Instead, the construction industry started to use of the engineering woods. Engineering woods such as GLT, they call it glue laminate timber, CLT, cross laminate timber. Some of these structure like GLT, CLT, MPP, the use of the glue to attach the different or a smaller layer of the wood. Let me show you. For example, take a look here. This one, they call it glue laminate timber. This can be used as a wall or as a roof or as floor. Okay, you see, there are so many small size of the wood attached with each other with glue. Now, when we talk about wood, we don't just think about the traditional wood, but think about also engineering wood as well. Or let me show you another one. Might be very interesting for you. This one, take a look. This one they call DLT. The proper size of the timber, as you can see here, 1, 2, 3, will attach to each other by dowel. That dowel also of the timber material. They make some holes in the wood and they align or set up the wall like that. There is no glued, there is no any other material we use to attach this lumber to each other. So later they can use it as wall, this material. Or another one, take a look here. This one, there is no glue, but use nail to attach the small size of the lumber. These have a stronger stability against displacement, against the loading. Also, it can be used for the different position in the building, wall, roof, floor. So when we talk about wood, I want you to think bigger. There are still more. I just wanted to make you familiar with the definition. This one, they call it NLT, nail laminate timber. This one, DLT, there is no glue, there is no nail. This one, blue laminate timber. If they change the way they put the lumber, it will be CLT, but still they use glue. But definitely two different products. So that's it. Now, there is another issue we are going to start discussion. They call it lean construction, which is for next week, value management and BIM or BIM, building information modeling, using of the software technology in the construction. Have you studied AutoCAD? I believe you did already. Am I correct?
Yes.
Okay.
Yes.
So you might remember what AutoCAD exactly do. You draw the building plan. But building information modeling is a professional software that at the same time handles so many work. I don't want to explain more. We will leave it for next week. We'll have discussion about it. But today we talk about constructability. In order to have discussion about constructability, I would like you to share with you a link. Okay, let's watch.
This video will explain constructability in 3 minutes. Are you ready? Well, come on then. Let's go. Remember Dave? Dave's a project manager on a large construction project. Dave's attending a portfolio update meeting this morning and learns that another project that his company is currently struggling with is 25% over budget and is currently 3 months behind schedule. In doing a project root cause analysis into the reasons for such poor performance, it was determined that many of the challenges that construction faced in the field could have been eliminated or mitigated during engineering design. Julia, the construction manager, and Mark, the engineering manager, both blamed each other for the poor project performance. Dave realized that the engineering, procurement, and construction teams had a poor relationship on this project, with each group existing as a silo. The contracting strategy that was used on the project brought construction in so late that the construction team did not have any opportunity to provide input into engineering design. Engineering invited construction to the 60 and 90% model reviews, but constructability is an ongoing process, and it's difficult to get good construction input in only a couple of meetings. And when construction came up with an idea of the 90% review, engineering said it was too late to change the design. No one appointed a construction subject matter expert to work with the engineering team to identify and mitigate construction roadblocks. Yet, the team said they did constructability. Poor Dave. Dave understands that proper constructability involves the integration of full-time construction knowledge and expertise throughout the project lifecycle, beginning at preliminary planning and design. Dave explains to his team that project cost influence decreases rapidly through the project lifecycle. As construction costs increase, the ability to reduce project cost declines as it's too late to implement many great constructability initiatives. Constructability experts are construction tradespeople that have actual hands-on construction experience. These individuals also have extensive supervisory and management experience that enables them to see potential roadblocks and issues that others would miss. The team works together to define the optimal path of construction and aligns the path of engineering to facilitate construction sequencing. Dave's construction experts use Bentley's ConstructSim platform to review the design and plan sequencing within each construction work area and identify roadblocks and design improvements that could improve construction performance. Constructability efforts allow you to optimize engineering design to minimize construction work done on site and allow you to ensure that work done on site is safe and efficient. This includes improving field weld locations, kitting studs, nuts, gaskets, and installation of module interconnect locations, and leveraging rope access personnel to minimize scaffold costs. On Dave's current project, the constructability team identified an opportunity to build all project scaffolds on the modules in the module yard and ship the modules to site with the scaffolds already built. This initiative reduced scaffold costs, reduced access challenges in over-scaffolding site areas, and had workers completing activities in a safer environment. Dave and his team have proven that early and continued investment in constructability initiatives reduces construction costs, reduces schedule durations, improves safety performance, and makes everyone happier. Another great project initiative, Dave. If you keep performing this well, that promotion will be coming sooner than you think. This video will explain
Okay, that's for this part, and just remind you some of the important things. When you want to submit your task, you have two tasks, right? Make it as one PDF file when you want to download it. The first page, task 1, the second page, your task 2. You shouldn't use pen, but rather use a Word file and make it PDF the time you want to submit it. And you have any question, please feel free to ask.
Doctor,
Yes.
we need to provide front page of each task.
No. Just 2 page enough, but write your name clearly, your matrix number. Do not need front page. Just in the top of each page, mention this is task 1, and the second page, write down task 2. That would be enough.
Okay, Doctor.
What's important for me is your report should be free of plagiarism and come out from your study. Okay? Any other question?
No, doctor.
Okay, if no question and you make your attendance already, you can leave the Google Meet. I will see you on next week. Have a good day.
Sir, sorry.
Yes.
If we use a reference to do the task, do we need to attach it in the report?
Okay. Use the reference as, let me I show you example. Use your reference as footnote. Okay, like this. Let me share the file with you. Take a look here as footnote, not in the separate file, okay? In the separate page. In the same page, use your reference.
Okay, sir, I understand. Thank you.
Okay, welcome. And when you want to upload your task, you can only upload once. So be careful, please. Be careful what file you're uploading, I mean. If you wrongly upload your file, then you cannot redo it again. And this is the link for your task. Task 1, task 2, you can upload this in individual, it's not group. Everyone should do for yourself, themselves. Okay, if you have no question, you can leave the Google Meet. If you have, you can stay here and discuss with me and ask your question.